Mike Milner. I'm CTO at Immunio. Immunio does runtime application protection for web applications. So this idea of security being really included in, I guess, DevOps, DevSecOps, really interesting to me, particularly talking with all you smart people here. So this slide's really more for me here, but when I'm thinking about what is DevSecOps, it kind of goes back to say, well, what is DevOps? And it's one of those terms everyone here has probably heard used, misused, overused. So I wanted to kind of get a baseline understanding, like, what is DevSecOps? Now, for DevOps, you've seen lots of organizations where really they've just taken their ops people and given them a new title, and now they're DevOps, but really nothing's changed. It's still a separate part of the organization from development. And then in other places, I've seen the setup where every single developer has to be full stack. They have to do everything from top to bottom, right down to infrastructure. But I also think that's a bit impractical. And I imagine most of you will agree that the sweet spot is really more in the middle. You still have specialists. You still have somebody specializing in operations. You still have people who are primarily developers. And with DevSecOps, you've still got people who are primary security specialists, but now they're working together as a team. And I think that team responsibility is the most important aspect of it. Thank you. It's that shared responsibility for an application. So if the application's not working properly, for any reason, the whole team has kind of got that shared responsibility to fix it. Because nobody wants something like this here. Now, I've seen this picture in quite a few DevOps presentations. I love it because it's very visual. The fire, the smoke. This is what I call sort of the ops fire, usually tied with availability. If the site is down, people know about it. The big, dark, thick, black smoke. People are angry because they can't access the site. Now, I did a little bit of reading about tire fires. Turns out they're really hard to extinguish. I don't know if everyone knew this, but they can burn for months. There's even one in Wales, I think, that burned for like 15 years. They're very difficult to put out. And it's sort of similar in operations. Once the website is offline, everyone knows about it. Your users know about it. It's had an effect immediately. But when you throw security into the mix, it's not just about availability anymore. Now you're looking at other factors: integrity, confidentiality, audit. And these types of security fires, if you will, are quite a bit different than this operation fire. Security fires aren't always quite as visible about as this. Often, the security problems in your code are quiet. Attackers are looking at your web application, they're poking, they're prodding, but they don't want to be detected. They're trying to be quiet and subtle about it. So it's a slightly different mindset, I think, to look at security issues in your code. Sometimes these security fires, you can have a vulnerability in your code that's lurking there for a while, and you might not even find out about it for days, months, even years after the actual attack happened. Take Yahoo as an example. They've been breached. I think it was a couple years ago that it actually happened, but the security fire is only really happening visibly now. Maybe someone at Yahoo knew about it and just didn't tell us. I don't want to speculate on that, but this vulnerability was exploited years ago. Didn't notice, and now they're paying the price of the security fire. And it got me thinking, in general, what do you do about these quiet, invisible security fires? And one of the things I liked most about DevOps, it was the idea that you could get this availability, you could get this thing running, continuously running, without affecting the flow of development, because among all this, you actually have to keep delivering features. You have to keep this application evolving. So we want something similar for security, the idea that maybe we can apply this DevOps idea of effective monitoring of your application to security. Operations has had pretty good monitoring for quite a while. This is just a little screenshot of a single chart from Datadog. If you're familiar with it, it's a great tool for logging lots of different metrics about your applications, your infrastructure. You can set up alerting. You can use it to test load on servers. It's really quite effective. It's a useful tool. But security, application security in particular, is kind of playing catch up a little bit. There isn't really a Datadog for security. But this idea of combining security with the development team and operations team early on gives us the ability to start trying to include some of these security monitoring concepts earlier into the process of an application being developed. So very early on, starting to think what might be useful monitoring information from a security perspective. Getting that baked into the application early as it's being developed instead of doing it after the fact. So I picked a particular attack type I wanted to just talk about briefly, and then we'll kind of look at what this idea of security monitoring might look like. Credential stuffing, these become much more popular over the past year. And by popular, I mean it's happening a lot more. People are noticing it a lot more. You've probably seen big headlines about breaches. LinkedIn was the big one not too long ago. Big password database leaked. And the interesting thing about this one, to me, is that somebody lost these credentials. They were breached, they were stolen, and that's probably due to a security bug. They had a vulnerability in their code or in their infrastructure. Somehow this data leaked. But now the leaked data is being used to attack many other sites with these credential stuffing attacks. And those sites don't really have a bug in their code necessarily. There's no bug that lets credential stuffing be effective. What the attackers are doing is they're just taking every one of these username password combinations. They're relying on the fact that around 50% of users will reuse the same passwords on multiple sites. And now they're going to your websites and they're just trying to log in with every one of these accounts, just trying to find one that works. And because it's not actually exploiting a bug, there's not really much in the way of protection on lots of sites. Because it's using a feature of the website, the ability to test a password and log someone in. So this is an example where putting the security with the development team, maybe we can identify these threat vectors early and put in the appropriate logging. If anyone's investigated something like this on an application, you might have started with something like this. This is, standard log, Apache common log format. If your application has no security logging, you probably still have something like this at least. It's just logging each request, the URL, the response status, IP address it came from. Maybe you can tell a little bit from here. You can see the get post, get post, get post. That's common if your login is protected against cross-site request forgery. You need to look at the login page, get that security token, put it into the login. It doesn't really affect or hinder somebody doing credential stuffing attacks. But one thing you notice here is the response code is 200 OK every single time. And this is because generally login forms don't respond with a forbidden error or 401 authentication required, because that pops up the ugly browser login form. They just return the login form again with a little red line that says, in unsuccessful login. But in terms of the logging, it's still just a successful response. So somebody monitoring your website on the operations side of things might be looking at your load balancer logs, your web server logs. Everything's 200 OK, right? 200 OK. But obviously a credential stuffing attack, these are valid requests. They look normal. They're using your site to test these logins. So what can we do now? Imagine we were writing this application from the start as a security person on the development team, what could we maybe do to our logging to support security monitoring in the future? So I'm going to walk through some progressions, and we'll kind of see how that'll help us be more effective. First thing, just adding a bit more structure. You've probably seen or heard about JSON-style logging. It's becoming more popular. The idea that you can have a bit more structure in your logs so that you can include a bit more information. Right now, we're seeing all the same data, but it's just maybe a bit more amenable to a computer processing it and doing some stuff. So as the application's getting developed, what are we going to add in to improve our monitoring? I recommend starting with giving every request a name. Give them an identity, an ID, so that you can now kind of track this throughout your system. Ideally, you'll want these identifiers being placed as early in your stack as possible, right at the edge of your network. As soon as that request comes in, maybe it hits your load balancer or something like that, give it a unique identifier, and then track that throughout your system, because that's going to be your unique way of correlating other logs with what we're getting here. Then you probably want to start capturing more information about where your requests are coming from. So these are login requests, so we don't have a username, but we can start capturing things like a user agent. If you've got a tracking cookie in your HTTP, you're actually tracking browsers, then throw that in there as well. These are all going to be useful bits of data to help correlate different behavior when we're actually trying to monitor and prevent these attacks. And then the most important thing is actually record what happened in some sort of a neutral format. So instead of trying to parse a log file, pull out 200 means this, and this type of response means that, just be explicit. You decide, because again, we're part of the development process now. We can decide at the start, failed logins are probably going to be interesting. Maybe you've done threat modeling and identified brute force as a possible vector, credential stuffing as a possible vector. So let's get that in there early. And maybe add some additional information. Which username did they try to log in as? Did that user exist in my system? Try to include relevant information in your logs that are going to be able to feed into your monitoring systems later to make tracking these types of attacks more effective. For other types of attacks that are more business-oriented, you can do something very similar. Instead of now tracking failed logins, maybe I want to track things that are more relevant to my business for less security use cases, but more abuse use cases. Credit card declined, probably interesting to know. I don't know if you guys are familiar, card scammers, credit card fraud. You can buy these big databases, lists and lists of compromised credit card details with the card details, but there's always a bit of a question from the scammers on, are these valid credit card details? Are they still active? So you might get a list of 10,000 card records from, I don't know, some online form or something like that, but you don't know which ones there are actually still working. So before you use them for your high-value fraud, whatever that might be, you want to test them. So we've had people come to us who run charity websites. Now, it's very common for charity to accept donations, and it's very common for donations to be small value. So a credit card scammer is trying to avoid fraud detection from the credit card companies, which are very good at spotting large, high-value transactions that might be a bit abnormal. But smaller transactions, $1, $5, might go by with less notice. So they'll go to a charity website, and they'll just feed in these credit cards, one after the other, trying to donate $1. And the ones that succeed are accepted. The ones that are declined are no good. They cross them off the list. So now this poor charity is getting lots of donations, hooray. But then at the end of the month, they all get rejected by chargebacks. So it's a major burden for these charities to bear. They're paying the price. So tracking these types of things lets you also protect against business logic errors, abuse cases. Once you have the information, then you can start using those for effective monitoring. And it's not always tied. I added in the username here because, you know, maybe you're a step higher up. Maybe you know a bit more about who's making the request at this point. There might be other information that's relevant for your website, but basically record it all. This is another use case that we've looked at where somebody was using credential stuffing. They were breaking into the accounts that were vulnerable. And this one happens to be like a loyalty point type system. So they were, every account that they logged into, they were taking the loyalty points, and this particular website allowed you to transfer them. They were transferring them to their own controlled account, their attacker one. So this is an example where this additional metadata can become really valuable. Each compromised account was just doing a single transaction, maybe not that suspicious. But in that particular use case, the destination account was always the same. So it gives you the ability to sort of slice and dice these things. So obviously for login, I want to control how many failed login attempts I'll accept from any particular source. If you fail to log in too many times, I want to do something about it, or at least take note. Similarly, by tracking the name that was attempted, I might want to track where they're all going. And all of these controls are based on the data that you're collecting from your monitoring. And yeah, the transaction use case was tracking now the destination account. So one particular account should not receive more than X number of transactions per day. That's anomalous, flag it up, monitor it. And another important thing is to have some kind of a response. If you spot these things happening, you want to be able to stop them, because sometimes they happen quite quickly. CAPTCHA is a classic one, but you could also block the IP, block the user account, force a password reset if you think the compromised or the credentials have been compromised. But you want to have some sort of a response mechanism. So baking that into the application as well, the ability to do some of these things based on your security monitoring is important as well, like set a flag in a database, and now that user will get a CAPTCHA. And in the spirit of sharing information, it's also really important to identify who needs to know. Security is now embedded within the team, but there's other parts of your organization that need to know and be involved in these same things. Talk to your fraud and abuse team if you have one. They've probably got lots of examples of things that they're looking for that they just don't have the data to get. So if you're that security person embedded in a DevSecOps team, talk to these other stakeholders in your organization. What does customer support need to know in case some of this stuff happens? Will they need to talk to the customers and help them understand that their account's been compromised? Maybe even help them set up some sort of identity protection. Same thing, your PR might have to post something on the blog to make this public. What information do they need to know? Engage with these people early so that, you know, as the keynote this morning said, really, you know, DevSecOps is really DevSec, stakeholder relations, public relations, compliance, you know, all of these things need to be working together. And then identify what they need to know. This is kind of part of engaging early. Once this stuff happens, if you can prevent it, if you can stop it, what do you actually need to know about the attack? What information do you need to collect? Some of this stuff is pretty big business. If somebody's stealing data or stealing finance, you might have compliance obligations that might require an investigation. So what do you need to actually collect that might need to be given to law enforcement? Or you might be able to use to defend yourself if somebody's trying to fine you. You might need to demonstrate that you've taken appropriate protection measures. So it's important to identify these things early, and that security person is the ideal person to carry these business requirements from security, abuse, compliance, into the development team so that they're identified early and you're not having to play catch up on your application to spot them after the fact. And that's everything. Thank you very much. Does anyone have any questions? We'll We'll pause a moment. Here, okay, here we go.
Okay, thank you very much for that talk. So how do you deal with confidential information? And especially, I'm not talking about explicit confidential stuff. You wouldn't put a password into the logging, but implicit confidentiality, like in Germany, you're not allowed to track employees, what they're doing. So we had this concrete problem in one of the last projects. We wanted to log very detailed, but we had to be explicitly compliant with the requirement of not tracking particular individuals. Have you had any experience with that?
Not that particular regulation. We've had issues where the inability to track the identifiers themselves. So maybe you can't track user Mike, but if you can strip that out, basically you've got one source where for the logging, the stuff that you persist, the stuff that you analyze in bulk to look for these security threats, only has an opaque identifier, like a hash or just a UUID or something like that. And then there's only one source of truth that maps that opaque identifier to the real user. I'm not sure if this particular regulations, if that would satisfy that requirement, but particularly something for internal users, you still want to be able to do the analysis. You still want to be able to spot that a particular account is doing something bad. But again, I'm not sure. You probably know better than I do whether it would satisfy that particular requirement. But
we're very puzzled by that challenge.
Yeah. But yeah, we've had a similar thing. So Immunio, the company, is a service, and some companies aren't comfortable that data going to us. So maybe a similar concept, they've done exactly that, an opaque identifier that we can share with them, but only they have the ability to map that to the actual user identity, like email address and username. Yeah.
Thank you.
Any other questions? There's one there. Yeah, you've got the job of sharing the microphone now.
Yes, I will bring it over.
Thank you. Just wanted to say that was really interesting because I've had to deal with that in exactly the way you've just detailed. Unfortunately, the hard way. And what was interesting was that in addition to all those people that you involved, we also involved security operations. So they were tracking the perpetrators through the threat intelligence. So during the whole remediation process, we were seeing both sides of the picture, right. And that really helped in trying to tailor our response to each of the steps, be it PR or customer services or whatever. But
yeah, absolutely.
Yeah,
it's really always a balance, I find. From a security perspective, you'd like to track everything. Who cares about privacy, right? It's always that balance. You know, I would love if every user had a unique identifier in their browser that I could track their behavior across all these sites. But of course, you know, balancing that is very important. But yeah. Anybody else had to deal with it the hard way for some of these attacks? I know I have, certainly. Yeah. Any other questions? All right, thank you. Oh.